Assalamualaikum. Hey guys, how are you? Alhamdulillah, I'm alive. I'm absolutely fine and I hope you are all well. Today we discuss the topic amino acid titration. Firstly, it is important to know that what is our topic, what we study in this topic. What are amino acids? Amino acids are the units of proteins. And what is titration? Why we do titration? Titration. Why we do titration? We do titration to check out the concentration and purity. Objectives: to study the titration curves of amino acids. What is titration curve of amino acids? When titration curves are obtained? These are the questions. Titration curves are obtained when the pH of given volume of the sample solution varies after successive addition. The curves are usually plots of pH against the volume of titrate added, or more correctly against the number of appropriate added per mole of the sample. To determine the pK values. Why we find or why we determine the pK values? What are the pK values? Why we determine the pK value of amino acids by titration? It's a question. We determine the pK values to find out the strength of acid. Next, to determine isoelectric point, Pi. What is isoelectric point? Pi. It is the pH volume at which the positive charge is equal to the negative charge. Also, to determine buffering regions. These are our subheadings, are our objective to study. Amino acids. General formula and classification. Amino acids consist of a basic amino group, an acidic carboxyl group, a hydrogen atom, a distinctive side chain. Classification: amino acids can be assorted on the basis of the general chemical characteristics of their R groups. Non-polar side chain. Non-polar side chain that doesn't bind or give off or participate in hydrogen or ionic bonds, e.g. alanine. Polar unbranched side chain. The R groups are not ionized in water, but it can be participate in hydrogen bond formation, e.g. serine. Acidic side chain. Negatively charged, contain CaO, e.g. glutamic acid. Basic side chain. Positive charge, contain NH3 positive. Examples are also here. Properties of amino acids. Amino acids are amphoteric, which means it can react an acid as well as an base. What is a base or what is an acid? Acid donate a proton and base accept a proton. Amphoteric properties of amino acids are due to the presence of their ionizable alpha amino and alpha carboxyl group. Can act sometimes as acids and sometimes as bases depending upon the pH of their media. Each amino acid have a different isoelectric point, Pi. It is the pH value at which the positive charge equals the negative charge. The net charge of these molecules equal to 0. That's Twitter ion. Amino acid titration. From the amino acid titration curve, we can get important information about amino acid, for example, pK and also Pi. Amino acids have more than one pK because it is polyprotic. Amino acids have more than one pK. Why? It's the question. Because it is a polyprotic, and what is meant by polyprotic? Polyprotic contain more than one ionizable groups. Also, it provides information about the buffering change of the amino acids, that is storage. Based on the number of bits on the titration curve, one can determine the number of dissociable protons. Titration curve of amino acid. Here we discuss the pK value of glycine by titration curve. The pK values of the amino acids are determined from full titration graph. To determine the pK1 and pK2, locate the volume on the graph halfway between the two point volume determined from the expanded derivatives curves. The pH at this point is the titration is equal to the pK1. At a very low pH, acidic both groups are fully protonated where the solution predominantly contains. What is meant by protonated? Protonated mean addition of protons. When the pH is raised, the COOH groups start to be deprotonated and the proportion will. pH is equal to pK1 where it will act as a buffer and the solution will contain an equal amount. Titration curve of amino acid. Further increase in pH, the solution will predominantly contain tritine and the pH at this point is equal to Pi. As the pH increases, the second group NH3 will be deprotonated. After that, pH is equal to pKa2 where it will as a buffer and the solution will contain an equal amount. The NH3 group will dissociate and at the same time the glycine will dissociate in endpoint. In diprotic amino acids such as glycine, the Pi is an average of the pK of carboxyl 2.34 and ammonium 9.60 groups. Thus, the Pi for alanine is calculated to be 2.34 plus 9.602 is equal to 5.97. The pH calculated by different way. At starting point, pH is equal to pKa plus P shared by 2 at any point within the curve after in and after middle. Titration pH is equal to pKa log inactivate way. At endpoint, POH is equal to pKb plus P reactive. pH is equal to pKw minus POH. Method. Experiment method. How we calculate or determine the pK value of amino acid by titration method. पहले हमने डिस्कस किया टाइट्रेशन मेथड, टाइट्रेशन कर्व के ज़रिए हम pK वैल्यू को कैसे कैलकुलेट करते हैं, PI वैल्यू को कैसे डिटरमाइन करते हैं. अब हम यहाँ पे एक्सपेरिमेंटेड से देखेंगे. Prepare 10 ml of alanine solution 0.5 m into a 50 ml beaker. Add 0.5 ml of 0.15 HCl from the beverage and determine the pH of the solution after each addition. Continue adding acid until pH falls to about 1.3. Wash the electrode in distilled water. Titrate a further 10 ml of alanine solution with 0.1 mNaOH until pH reaches 12.5. Plot a titration curve for alanine pH versus trend in ml. Do the titration of arginine in a similar way and plot their titration curves. Record the titration table and plot a curve of pH versus ml of NH and HCl added. Determine the pK and Pi values from your curves and compare them with the standard values. For alanine, pK1 is equal to 2.34, pK2 is equal to 9.69, Pi is equal to 6.01. For arginine, pK1 is equal to 2.17, pK2 is equal to 9.04, pK3 is equal to 12.48, Pi is equal to 10.76. So guys, we studied how we find or calculate the pKa and Pi values of the amino acids by titration method. All is clear. How? Thank you and Allah Hafiz.